Hello students, this is Nilanjana Sanyal from My Math Friend Online and ePorashna. We have done sessions on quadratic equations, but we had left the derivation of the quadratic formula. So in today's session, we will be doing that. We will be deriving the quadratic formula. Okay, so let's start. First of all, let us write the general quadratic equation. General quadratic equation is ax squared plus bx plus c is equal to 0, where e is the coefficient of x squared, b is the coefficient of x, and c is the constant term. Okay. Now we will be solving for x by the help of the completing the square method. Okay. Now do you remember what did we do when the coefficient of x square was not a perfect square term? Right. We had multiplied the entire equation by the coefficient of x square so that the first term becomes a perfect square term. Right? E is a variable, so it can be a perfect square number or it can be any other number as well. Okay. So you may argue that why should we take e to be a non-perfect square term? Why should we take e to be as 3 or say 6 or any other number which is not a perfect square? A can be 4, a can be equal to 9, it can be equal to 16 as well. Right. You're absolutely correct. Suppose e is 4. We will be having 4x squared as the first term. If a is equal to 4, then the first term will be 4x squared. If we multiply the entire equation by 4, that is the coefficient of x squared, we will be getting the first term as 16x squared, which is 4x whole square. Even if we multiply the entire equation by 4, that is the coefficient of x squared, that is by the coefficient of x squared, we still get a perfect square term. We get a 16x squared, which is 4x whole square. So it doesn't matter if a is a perfect square number. Okay. Even if a is a perfect square number, on multiplying the entire equation by a, we will be still be having a perfect square term as the first term of this quadratic equation. Okay. So let us multiply the entire equation by this coefficient of x squared, that is a. Okay. So we do that. When ax squared is multiplied by a, we get the term as a squared x squared. Next is the plus sign, and a multiplied with bx will be giving us an abx, and next is ac is equal to 0. Okay. Now what did we do? We will be introducing a term after this abx, after this term containing this x, so that we can group the first 3 terms and we can express the 3 terms in the form of a plus b whole square identity. Why a plus b whole square and not a minus b whole square? Because there is this plus sign over here. We have a plus sign, so we will be going for a plus b whole square identity. If it was a minus sign over here, then we would have gone for a minus b whole square identity. So we will be choosing a plus b whole square or a minus b whole square depending on this sign. If it is a plus sign, we will be going for a plus b whole square identity. And if it is a minus sign, we will be taking the a minus b whole square identity. Okay? So we write the first term in the form of a whole square, that is ax whole square. Ex when squared will be giving us a squared x squared. Okay? Next we write the plus sign. And what is the expansion of a plus b whole square identity? The first term is a square, second term is plus 2ab, and the third term is plus b square, right? So the first term is in our case ax whole square plus. Next we will be having a term containing 2, a factor of 2, and then multiplied with the first term and then the second term. So first of all, let us write 2. Then we write this first term, that is ax. Next we are having abx, but over here we are having 2ax and not abx. How to get this abx from this 2ax? Okay, let us see ex. This part is common to both the terms. Ex is common. Only missing factor is b, so let us write this b. We have to get b, so we are writing b. We will be writing this b. Next, what to do with this 2? We are having this extra 2, which should not be. This 2 is absent over here, so this should not be present in this case as well. But we have to have a 2 in order to get the expansion of a plus b whole square identity. So what do we do to this 2? We divide this b or this entire term by 2 so that these two 2's can get cancelled. If we write b by 2, then this 2 in the denominator and this 2 in the numerator will get cancelled. And we will be having exb or abx, which is the term that we are having over here. Okay? So always do write the 2 first, then write this term ax in our case. Next, see what is left from the original term in the above equation. Write those factors. And next, see what all extra factors do you have. Divide those extra factors. Okay? Next, we have got ax whole square plus 2 times ax times b by 2. So in order to get the third term of a plus b whole square, we should be squaring this b by 2. So we write that. Plus b by 2 whole square. We have to have this because otherwise we cannot complete this a plus b whole square form. We will not be getting the a plus b whole square identity form. Now we have introduced this new term b by 2 whole square. But we cannot introduce any new term in an equation because the value will get changed. So as soon as we add a new term, we have to subtract that as well. So we write minus b by 2 whole square plus ac is there equal to 0. Okay. Now these three will get combined to form ax plus b by 2 whole square. Okay. And this is minus b square by 4 plus ac equal to 0. Now, this is a fractional number, fractional form. This is in fractional form, and this does not have any denominator. So if we want to sum them up, what do? We take the LCM of these two terms. So the denominator will be 4. So we do that. Ax plus b by 2 whole square, we keep it as it is. And for these two terms, we take the common LCM as denominator as 4. And since this b square by 4, for this term, we are having a denominator of 4. So the numerator will be b square. And let us put a bracket. I have put a minus sign because there is the minus sign over here. I have put a minus sign and I have put a bracket. Since I have taken this minus sign outside, I am not attaching another minus sign with this b square term. Okay, you should be careful about this. And next comes this AC term. It doesn't have any 4 in the denominator. Instead, it is having a 1 in the denominator. And over here, there is the 4 in the denominator. So this term should be multiplied with 4. So it will be 4AC. Now, what will be the sign in between? It is a plus sign over here. But since we are enclosing these two terms within the bracket and in front of the bracket there is the minus sign, we have to put a minus sign between these two terms because minus and minus when multiplied together will be giving us a plus 4AC. It is a plus AC and we have taken this common denominator, so it should be a plus 4AC. Since we have taken this minus sign outside the bracket, so we have put a minus sign in between these two terms because these two minuses will get multiplied together to give us a plus sign. Okay. This is equal to 0. Now, we will be taking the help of the a square minus b square identity. And for that, how can we make this part a square number? This 4 is a square number. It is 2 square. How can we make the numerator to be a perfect square? Let us see. We keep the first part as it is. Next is the minus sign. Now, if we put this whole of the numerator within the radical sign, under the radical sign, and we square it. Can we do this? Can b square minus 4ac be written as under root b square minus 4ac whole square? Right, it can be written. And 4 is nothing but a 2 square, right? Equal to 0. So we can combine the numerator and the denominator. Let us first of all write the first part. And this can be written as under root b square minus 4ac by 2 whole squared equal to 0. Okay. Next, we have got the a square minus b square identity form. A is representing ax plus b by 2 and b is representing this part under root b square minus 4ac by 2. So what was the expansion of a square minus b square algebraic identity? Right. It is equal to a plus b into e minus b. So we write that. This is ax plus b by 2. This part, the whole of this part, that is the two of the terms, constitute the a part. And next is this part, plus b square minus 4ac by 2. Okay. And again we will be writing ax plus b by 2 because the whole of this is equal to a, and minus b. B is this part. So we write b square minus 4ac by 2 equal to 0. Okay. Now, since these two bracketed portions when multiplied together is giving us a zero product, therefore we can say either this part is equal to 0 or the second part is equal to 0. So either ax plus b by 2 plus under root b square minus 4ac by 2 is equal to 0. If this be equal to 0, then what will be the value of x? We keep this term containing x on the left hand side of the equal to sign when we take both these two constant terms to the right hand side of the equal to sign. Both are having plus signs, so both will be changed to minus signs, and both are having the same denominator 2. So it is minus b by 2 and minus under root b square minus 4ac by 2. Okay. Next, we have to find the value of x and not ax. So we take this a to the other side, to the right hand side, so it goes down as the denominator. And since we are having the common denominator, so we can join these two terms. We will be having 2a, a is brought down, and it is minus b minus under root b square minus 4ac. Okay. So one of the two values of x is minus b minus under root b square minus 4ac by 2a. Okay. Where b is the coefficient of x, a is the coefficient of x square, and c is the constant term. Let us see what is the other value for x. For that we have to look at the second part. It is ax plus b by 2. Let us write ax plus b by 2 minus under root b square minus 4ac by 2. It is minus b square minus 4ac by 2 equal to 0. Either this part is equal to 0 or this part is equal to 0. Now we will be solving for x from this equation. So we keep this term containing x in the left hand side of the equal to sign, and we take the two constant terms to the other side, that is to the right hand side of the equal to sign. So plus b by 2 becomes a minus b by 2, and minus under root b square minus 4ac by 2 becomes a plus under root b square minus 4ac by 2. Okay, and next we have to bring this a to this side, to the right hand side, so it will be coming as the denominator term. So we have x equal to, and both of these two terms are having the same denominator, so we can combine them. So we have 2a in the denominator, and in the numerator we have minus b plus under root b square minus 4ac. Okay. So we are having either x equal to minus b minus under root b square minus 4ac by 2a, or we are having x equal to minus b plus under root b square minus 4ac by 2a. Only difference between the two values of x is in these two signs. You see minus b over here, also we are having minus b. The under root part is also the same for both the cases, b square minus 4ac. Also the denominator is the same, it is 2a. Only difference lies in these two signs. In the first case, we have found that it is a minus sign, and over here we are seeing that it is a plus sign. So we can combine these two results and we can write it as x is equal to minus b plus minus under root b square minus 4ac by 2a. This is the quadratic formula. Since we are dealing with a quadratic equation, so it is obvious that x will be having two values. One of the two values is minus b plus under root b square minus 4ac by 2a, and the second one is minus b minus under root b square minus 4ac by 2a. This is the quadratic formula. So let's highlight it. Okay. Now we can stop over here. We have got the quadratic formula. We can stop over here, but I would like to show you some other method as well. Yesterday, one of my students asked me an intelligent question. She said that instead of multiplying the entire equation by the coefficient of x square, what if we divide the entire equation by the coefficient of x square? So let us first of all write the quadratic equation once more. It is ax square plus bx plus c equal to 0. We have multiplied this entire equation by the coefficient of x square, and we have got a square x square plus abx plus ac equal to 0. She said that if we divide this entire equation by a, we will be getting x square, which is a square term. We want a square term as the first term. That's why we have multiplied the entire equation by a square, a, to get a square, so that we can write it as ax whole square. So if we divide this entire equation by a, we will be getting x square, so it is x whole square. So why not divide the entire equation by a? It's absolutely correct. You can do that. You can divide the entire equation by a. Only thing is you will be getting a fractional coefficient of x as well as a fractional constant term. So I think that whole numbers or integers are preferable to fractions. That's why I have asked you to multiply rather than divide. You can do this as well. I'll be showing you how to derive the quadratic formula by using the same completing the square method. And I will be dividing this entire equation by a. So on dividing the entire equation by the coefficient of x square, we get x square plus b by a x plus c by a equal to 0. Okay. Now, since this is a plus sign, we have to take the a plus b whole square identity. So we write this as x square plus 2 times, it will be x over here. Now we are having x and we are having a b by a as well. So we write b by a. We have to have this b by a, so we will be writing b by a. But what should be done to this extra 2? We have to get rid of this extra 2. So we write 2 in the denominator as well, so that these two 2's can get cancelled. We have to have this 2 because in the a plus b whole square expansion, the middle term contains 2. So we have to write this 2. But in the original term, there is no 2. So we have to divide with the 2 as well. Okay. So that on multiplying this x with b by a, we will be getting b by a x. And we will be introducing the third term, that is, this is 2, this is x from the first term, and this is the second term, b by 2a. So the third term will be b by 2a whole square, obviously. So it is b by 2a whole square. But since we cannot insert any new term in an equation, we have to subtract b by 2a whole square as well. So we do that. And there is the constant term c by a equal to 0. Okay. Now we take these first three terms, and we combine them to get x plus b by 2a whole square. Now coming to these two terms. Let us first square this. It is minus b square by 4a square. And this one is a plus c by a equal to 0. Next, we see that if we just want to add these two, what will be the LCM of these two, 4a square and a? It will obviously be equal to 4a square. So we do that. We keep the first part as it is. It is x plus b by 2a whole square, and we take minus sign outside and we put 4a square in the denominator, and as before we put a bracket. We are having b square from the first term over here, and since the denominator of c by a is a and we are having the denominator as 4a square, so we have to multiply this c with 4a, right? So we write 4ac equal to 0. This part is also the same. Now coming to the in-between sign. What should be the in-between sign? Since we have taken out this minus sign outside the bracket, it should be a minus sign inside the bracket as well, because this minus when multiplied with this minus will be giving us this plus sign. So since we have taken out this minus sign, we have to have a minus sign over here as well. So it becomes b square minus 4ac by 4a square. Next, we want to take the help of the a square minus b square identity. So we have to make this a perfect square term, or we want to express this in a form of a perfect square. So we write this first part x plus b by 2a whole square, and 4a square is 2a whole square. Nothing to worry about that, and we know how to get this converted to a perfect square form. We have done this, the same thing over here. So we write it is under root b square minus 4ac whole square divided by 2a whole square, right? So now we would like to combine the numerator and the denominator. So we write equal to 0, of course. So we write x plus b by 2a whole square minus b square minus 4ac by 2a whole square is equal to 0. Okay. Next we see that we have got this in the form of a square minus b square identity. This whole part represents a and this whole part represents b. So what was a square minus b square equal to? It was equal to a plus b times a minus b. So we write that. First of all, we write the a part, that is x plus b by 2a plus the b part, that is under root b square minus 4ac by 2a, and there is the a minus b part as well. So it is x plus b by 2a minus under root b square minus 4ac by 2a is equal to 0. Okay. So either this part is equal to 0 or this part is equal to 0. So let us first of all take this part to be equal to 0. So either x plus b by 2a plus under root b square minus 4ac by 2a is equal to 0. So what will be the value of a if this is equal to 0? This implies we keep x to the left hand side of the equal to sign and we take the other two terms to the right hand side. We have minus b by 2a and this is minus under root b square minus 4ac by 2a. So if both of these two terms are containing the same denominator, so we can combine them. x is equal to 2a, and this is minus b minus under root b square minus 4ac. Okay, so we have got one of the two values of x. Now coming to this part. So or x plus b by 2a minus under root b square by minus 4ac by 2a. So it is minus under root b square minus 4ac by 2a equal to 0. And now we keep this x to the left hand side and we take the other two terms to the right hand side. So x is equal to plus b by 2a becomes a minus b by 2a. And since this is a minus sign, it becomes a plus sign. And it is under root b square minus 4ac by 2a. Again, we are having the same common denominator for both the two terms, so we can combine them. We can write this as 2a, and this is minus b plus under root b square minus 4ac. Okay, so we are having the two values as minus b minus under root b square minus 4ac by 2a, and over here minus b plus under root b square minus 4ac by 2a. The same two values that we have got over here, because it is the quadratic formula. So we can combine these two values of x and we can write this as x equal to minus b plus minus under root b square minus 4ac by 2a. This is the quadratic formula. So we see that we have arrived at the same result, same two values of x, once by multiplying the entire quadratic equation by the numerical coefficient of x square, and next by dividing the entire equation by the numerical coefficient of x square. Right? Now both of these two methods are at your service. You can choose. You are completely at liberty to choose any one of them. It is totally up to you. Okay? So students, this brings us to the end of this session. Thank you for hearing.